In this example, a student hangs a spring from the ceiling. The student then puts a mass on the spring, and the spring stretches. It stretches a total distance of 2.51 centimeters. And the question is, if the mass is 451 kilograms, what is the spring constant of the spring? Now it's easy to understand why the spring stretches. The weight of the mass exerts a force pulling the spring downwards. As a result, the spring stretches. But why doesn't the spring continually stretch and stretch and stretch further and further? The answer is that as the spring is stretched, the spring exerts a restoring force in the opposite direction, trying to pull the mass back up. And the spring will eventually come to rest at the point where the restoring force that it is exerting on the mass is equal to the weight of the mass as it's hanging on the spring. At that point, the system is in equilibrium and everything stops. So if we want to figure out the spring constant, what we have to first do is figure out the weight of the mass. That's easy. We have its mass, so weight is simply m times g. The mass is 451 kilograms, g is 9.8 meters per second squared. So the weight of this mass is 4.4 times 10 to the 3 newtons. Now remember, in order for the spring to stop stretching, it must exert an equal and opposite force back on the mass so that the sum of the forces is 0. Well, the force that the spring exerts can be calculated with equation 10.1. F equals negative k delta x. Alright, well we know what F has to equal. F has to equal 4.4 times 10 to the 3 newtons. That way the sum of the forces on the mass is 0. We don't know k, but we do know delta x. Delta x is the distance that the spring stretches once the weight is attached. That's 2.51 centimeters, or to get it into proper units, 0.0251 meters. Now it's negative because it stretches downwards, and downwards is negative. So now we can solve for k by simply dividing both sides by 0.0251 meters. When we do that, we get 1.8 times 10 to the 5th newtons per meter. What does that number mean? It means for every meter that the spring is stretched, it pulls back with a force of 1.8 times 10 to the 5th newtons. So this is a pretty strong spring.